So this section from day 3 of Trig is actually from section 4.4 in the textbook. No, not 4.4, sorry, section 4.3 in the textbook. Okay, and the examples that we're going to be looking through are going to be types of questions that you might see on standardized tests, but then also just good practice with becoming familiar with what the ratios for the trig functions are in terms of x, y, and r. So this first type of question that we're going to look at is where we're going to determine what the six trig functions for the angle theta are equal to, given that the terminal side of the angle theta passes through the given point. So we're not actually determining what theta is, although you eventually would be able to determine what theta was after we've studied inverse trig functions, but we're saying we're stating what the ratio is for each of the six trig functions. Okay, so the way that we're going to start this type of problem is by drawing a picture. So the point 8, 4 lies in quadrant 1. So I'm just going to do a sketch of what that looks like. I have my x and my y axis. X is 8. Y is 4. Okay, so if that's the point 8, 4, here's the terminal side of the angle theta. And theta is in standard position, so its initial ray is on the x-axis, the positive x-axis, so this angle would be theta. Okay. Now remember, all six trig functions can be written in terms of x, y, and r. Like cosine of theta is x over r, sine of theta is y over r, tangent of theta is y over x, and then the reciprocals, secant of theta is r over x, cosecant of theta is r over y, and then cotangent of theta is x over y. So notice that here, since we're given a point that the terminating side of angle theta passes through, we know what x and y are, but we need to determine what r is. And r, remember, is the distance of the point from the origin. So the way that we could find r is by using Pythagorean theorem, and that's because you could think about if we were to construct a right triangle here, and this will be true for any quadrant. If we were to construct a right triangle, this side would be 4, this side would be 8. So r squared equals to 8 squared plus 4 squared. So we would get r squared equals to 80. And then r is going to be positive. It represents a distance. So r will equal to the positive square root of 80, which is 4 root 5. Right, 16 times 5 is 80. Yes. Okay, so cosine is x over r. So that means cosine is 8 over 4 root 5, which we want to simplify that. So that would be equal to 2 over root 5, where then if we rationalize by multiplying by root 5 over root 5, we get 2 root 5 over 5. For the reciprocal, so cosine of theta is equal to 2 root 5 over 5. To determine its reciprocal, I'm going to go back to cosine of theta is equal to 2 over root 5. So the reciprocal would be root 5 over 2. Which if you did 4 root 5 over 8, which is just r over x, we could see that that would also simplify to root 5 over 2. Okay, for sine of theta, sine is equal to y over r, so y is 4 over 4 root 5. So that would be 1 over root 5, where when we rationalize the denominator, we get root 5 over 5. Okay, the reciprocal would just be root 5. Tangent, y over x. So 4 over 8, which is 1/2. And the reciprocal would be 2. Okay, so I'm not going to go through all of these. We didn't go through all of these in class. We'll go down. Let's do C. Well, we did D in class, but I'll do C. So -9, -5, that's quadrant 3. So I'll draw my xy plane. Okay, if this is -9, -5. Okay, so in standard form, so the initial side of theta is on the positive x-axis, and then the terminating side of theta will pass through the point -9, -5. So this angle right here is theta. Now, if we were to construct, say, a reference right triangle, we would be dropping a perpendicular there. Okay, so the side would be -9. It would actually be a length of 9. Right, this is -5, and we need to determine r. Okay, so we can, again, Pythagorean theorem, r squared equals to -9 squared plus -5 squared. So r squared ends up being 106. So r will be equal to the square root of 106, which I do not believe that simplifies anymore. Yeah, no. I think it's just the square root, or let's see. Yeah, just the square root of 106. Okay, so cosine of theta, which is x over r, would be -9 over the square root of 106. When rationalized, when the denominator is rationalized, that would be -9 root 106 over 106. Okay. Just make sure that doesn't. Yeah. Doesn't simplify anymore. Okay, so then secant of theta would be the reciprocal, so negative root 106 over 9. Okay, sine of theta is y over r. And rationalizing the denominator, we would have negative root 5 times the square root of 106 divided by 106. Its reciprocal, cosecant, would be negative root 106 over 5. Tangent of theta, y over r, would be negative 5 over -9, or 5/9. And then cotangent is its reciprocal, 9/5. Okay, and then notice that theta is in quadrant 3. And the sign, SIGN, of each of these trig functions matches are all students take calculus, right? Quadrant 3, only tangent and cotangent should be positive. And then the other 4 trig functions should be negative. Okay, so let's move on to the next type of question that I want you to be familiar with. Okay, so to determine the angle, to determine which quadrant the angle terminates in, you're going to think back to my little memorization tool. All students take calculus. Okay, so cosine is going to be negative in quadrant 2 and quadrant 3. Sine is positive in quadrant 1 and quadrant 2. So the overlap there ends up being quadrant 2. So therefore, the angle theta must terminate in quadrant 2. Okay, so for where the quadrant in which tangent is negative and sine is positive, tangent is negative in quadrant 2 and quadrant 4. Sine is positive, we already said, in quadrant 1 and quadrant 2. Okay, so the overlap again ends up being quadrant 2. Okay, so we want to know which quadrant both cotangent and sine are negative. Cotangent follows tangent, it's reciprocal. So cotangent will be negative in quadrant 2 and quadrant 4. And then sine is negative in quadrant 3 and quadrant 4. So the overlap here is quadrant 4. Okay, and then the final type of question that I want you guys to be familiar with how to approach is whenever you're being asked to state what the value of a trig function is given some other information. So in this case, we are trying to determine what tangent of theta is equal to, what the ratio for tangent of theta is. If cosine of theta is equal to 40 over 41, so this is our given, and theta is going to lie in quadrant 4, meaning theta will terminate in quadrant 4. I'm going to draw the picture. Okay, so quadrant 4 is down here. Cosine, remember, is x over r. So in quadrant 4, that means that the point in which theta, the terminating side of theta, will pass through, will have to have an x coordinate of 40. We don't know the y coordinate, and then the r coordinate will, the r value will have to be 41. So the distance of the point from the origin will be 41. Tangent of theta. So we're being asked to find tangent of theta, which remember is y over x. So we need y, and we can use Pythagorean theorem. Okay, so y squared will end up being equal to 41 squared minus 40 squared. Which is 81. If we take the square root, we are in quadrant 4, so y should be negative in quadrant 4. So we'll get negative 9 for y. So that means that tangent of theta will be equal to negative 9 over 40. And that does not simplify anymore. Okay. right? So in this case, we're being asked to find cosine of theta. We are given that tangent of theta is equal to negative 5/12. Okay, and theta will terminate in quadrant 2. Helps me to draw the picture. You don't have to draw the picture, but it can help me to follow your work if you draw the picture as well. Okay, the initial side, so for an angle that's in standard position, we assume that's in standard position, its initial side will be on the positive x-axis. Okay, quadrant 2. Tangent is y/x. So y is positive in quadrant 2, meaning y will be 5. Y will be 5. And x will then have to be negative 12. And we can determine r by using Pythagorean theorem. Okay, do we need r? Yes, we need r because we are being asked to find the cosine of theta, which is x/r. So Pythagorean theorem. Where r squared is equal to 169. R has to be positive. It represents a distance, so r will be 13. Therefore, cosine of theta will be equal to negative 12/13. Okay, we are going to look more at solving trig equations in chapter 6, okay? But for now, we're going to look at these basic trig equations, which we can just solve by inspection. So basically by looking at the equation and thinking about our unit circle in order to determine the solutions to the equations. So what values for theta would make this statement true? So for all the possible values of theta between 0 and 360 degrees, for sine of theta equal to root 3/2, that means that theta, okay, so we can think about this. Sine is positive in quadrant 1 and quadrant 2. So the quadrant 1 angle would be 60 degrees, and then the quadrant 2 angle would be 120 degrees. Okay, so that's your quadrant 1 solution, your quadrant 2 solution. Okay, so cosine of theta equals to negative root 2/2. Cosine is negative in quadrant 2 and quadrant 3. So in quadrant 2, 3π/4. Oh, not 3, sorry, we're in degrees. So 135 degrees would be our quadrant 2 solution. And then in quadrant 3, 180 would be 225 degrees. Make sure you have the degrees, okay? If you don't have the degree symbol, then your angle is technically in radians. And like 60 radians is not the same as 60 degrees. 60 radians would not make sine of theta equals to root 3/2 a true statement, but 60 degrees does. Okay, so now notice that the domain over which we are solving for is in radians, so our solutions are going to be in radians. Tangent is negative in quadrant 2 and quadrant 4. Okay, so in quadrant 2, tangent of theta will be equal to, what was that, 3π/4? Okay, and then in quadrant 4, that would be 7 pi over 4. All right, for secant of theta equals to 2 root 3 over 3, it might be helpful to think about, okay, that means that cosine of theta would be the reciprocal. So 3 over 2 root 3, which if you rationalize the denominator there, you get that cosine of theta is equal to root 3 over 2. Okay, so we can think about solving the equation cosine of theta equals to root 3 over 2 in order to solve the equation secant of theta equals to 2 root 3 over 3, if that's a little bit easier for you. Okay, cosine is positive in quadrant 1 and then quadrant 4. So in quadrant 1, cosine is equal to root 3 over 2 at pi over 6. And then in quadrant 4 at 11 pi over 6. You don't have to write down the quadrants. I'm just putting them down for reference. Okay. All right, so that is it from section 4.3.